Welcome. I'm Professor Sever. Today we're going to look at implicit differentiation. So here we have an equation involving x and y, where we assume y is a function of x. The goal here is we want to find dy dx. Okay? So we're going to take the derivative of both sides implicitly. Let's see what we get. So the derivative of x squared is 2x. Now, notice here we have a product of x and y. So we need a product rule here for this piece. So let's do it. Let's move the 2 out front. So now we're considering the product to be x times y, not 2x times y. You have to handle the 2 in one of two ways. Either you group it, namely, let's say with the first term, which is x, and that would be 2x times y, or you just move it out front as I did. So now the derivative of x is 1, derivative of the first times the second, plus the derivative of the second, which is dy dx. What is the derivative of y? It's 1 times y prime, or 1 dy dx, or just dy dx. So the derivative of the second times the first. Okay. Now that is just the derivative of xy. Now we move on to this term, plus the derivative of y squared, which is 2y, again, don't forget, times the derivative of the inside function, which would give us just dy dx. What's the derivative of any constant? 0. Okay. Solving, we need to distribute. So we get 2x plus 2y plus 2x dy dx plus 2y dy dx equals 0. I'll move the 2x plus 2y over, and I'll factor on this side. So I have dy dx, that's called factoring, times 2x plus 2y is minus 2x minus 2y. Final step, dividing by 2x plus 2y, and then we'll cancel. Dy dx is equal to we factor out a minus 2. Factor out a 2 in the denominator. It's not lined up very well. So we have minus 1, assuming y is not equal to minus x. Okay? And so finally, what's the answer? Dy dx is, I'll write it over here. Running out of room, I want to leave room for the second problem. So what have we shown? Dy dx is constant minus 1 when y is not equal to minus x. All right, very good. Now, this problem. Now, just as we had a product rule here, well, if we have x divided by y, that's a quotient rule. And if we have y divided by x, that's a quotient rule. So on the left-hand side, if I were to do this in the traditional fashion, I would have the two quotient rules to deal with. Okay? Well, maybe I don't want to do that. Certainly we can, it's not a problem, but I want to illustrate a technique. Let's multiply both sides by x times y. Okay? Or let's do 2x, 2 times x. Y, to get rid of all the fractions, to clear the fractions. So if we multiply both sides by 2xy, why would I do this? Well, let's see. You may say, I wouldn't have thought to do that. Well, and you may be right, but again, we don't live in a vacuum, so once we see the technique, we're free to employ it again. You'll see precisely why I do it. Okay, now, notice, let's distribute. The y's cancel. 2x times x is at 2x squared. When you distribute this piece times this one, the x's cancel, giving you 2y squared. And here the 2's cancel, giving you 5xy. Now, much simpler. Instead of 2 quotient rules, we'll have what? 1 product rule. So now let's do the derivative, okay? So now we're beginning the derivative of this form. What's the derivative of 2x squared? Well, it's 4x. What's the derivative of 2y squared? Well, it's 4y dy dx. Again, the goal, same goal, find dy dx, which I didn't write. Now we do the derivative of the right-hand side. 5, I'll just move out. Another product rule, the derivative of x is 1, so it's the derivative of the first term times the second, plus the derivative of the second term. Second term is y, so its derivative is dy dx times the first. And now we just simply solve for dy dx. Let's multiply out on the right-hand side, and I'm going to do both steps at once. I'm going to multiply this out, 5 times y, 1y, or y is 5y. 5 times this is 5x dx, 5x dy dx, and I'll bring all those over. So I'm going to get 4y dy dx minus 5x dy dx is equal to 5y minus 4x, solving, factoring dy dx. So let's see, I'm going to do this in one step. I'm going to factor the dy dx on the left-hand side, giving me dy dx times 4y minus 5x, and then I'll divide by that. So it's 5y minus 4x over 4y minus 5x. And there's the answer. In that form, namely where I cleared the fractions, I took the derivative in this form. Now let's see what would happen if in the space remaining. If I can do it, I might have to write small. Let's do the derivative. How would it have looked in an alternate method where I would have done no manipulation? All right, well, different answer. So is it wrong? Not necessarily, okay? We have 2 different forms of the answer. So we have 2 different forms of the answer. Are either of these incorrect? Not necessarily. Remember, I multiplied through. There were no denominators in this technique. I multiplied through by 2xy, clearing the denominators, then took the derivative of the equation in this form. Here I did it straight from the problem description. 2 different versions of the quotient rule, which is more difficult for most students. That's why this way is a little superior. So the answers look different. Well, I could factor a y, but you see there'd be no cancellation between the numerator and the denominator. I could factor an x. They just don't look the same. This is very simple. The reason is they agree on their common domain. Okay, so where these 2 functions have a common domain, namely where this is not 0 and then this term is not 0, when you intersect those 2 domains, these answers will be equivalent for each ordered pair xy. All right, very good. And you can see you can get different forms of answers in these kinds of problems depending upon the technique. Thank you.